Regarding the exam, I turned in the exams for processing this morning, and I'll have those results this afternoon, unless something goes wrong on their end. And then I'll post the numbers this weekend, so you can see how you did. Yeah.
The essay we're supposed to do it on actual exam.
Yeah, you have the space right there, right?
Okay. I didn't. Wait, we were allowed to write on that, right?
Sure.
Like the rest of it, not just.
Yes.
Okay.
Absolutely.
All right. So I was like.
You can, the exam that you have, the actual exam, you're free to write, and I encourage you to show all your work in case something goes wrong with the Scantron, you're transferring and you want to come in after the exam and look things over. There's a chance sometimes you'll end up getting some points back if you follow through. So show all your work on the exam. But if I never hear from you, you're going to get the score according to the Scantron results. Okay.
Are you still going to do that thing where, like, if we did well enough in the pretest?
Yeah, yeah. But that won't get added in until the end of the semester. So you won't see, all you're going to see on Blackboard is raw scores. Okay, so when you go to Blackboard, if it's trying to calculate an overall score or compilate a grade for you, just ignore that. The only thing I use Blackboard for is to keep track of all the individual scores. If you want an idea of your grade, your test average is a good baseline for your grade. And then if you want something more specific than that, then just talk to me, okay? And just talk to me. Okay? All right, so here's our list about constant rate, and we just added this last one that you kind of had a little problem, number 2, where you saw the change in x in 3 different places was the same, and it resulted in a consistent change in y. Okay? So that's still yet another one. So that kind of finishes our list. There could be more to the list, but this is certainly a good one. So I just want to give you a quick kind of visual, kind of starting with number 7. So if we have constant rate of change, then x and y are in a linear relationship. It forms a line in the Cartesian plane, and that's what we're going to focus on today. So I want to give you just a quick visual overview of constant rate of change. So if you want to review this, go to the video. Don't try to take notes, okay? Just absorb as much as you can. It should all make sense because it's review. And then go back to the video if you want to see it again, okay? So constant rate of change. 2 quantities vary together. Constant rate is, here's that one we just talked about. Equal changes in one quantity result in consistent changes of the other, okay? The change in one quantity is a constant multiple of the corresponding change in the other. And we said maybe this is the one we're going to use the most, okay? We're going to see this over and over again. And then the last one's the relative size of corresponding changes of the quantities is constant. Okay, so the relative size of the change in y to the change in x remains constant. So these constant rate of change relationships are linear. So here's just a generic line. So let's talk about that first one. Equal changes in x. So whenever you apply an equal change of x, the resulting change in y will be consistent. So that's the visual for that. If you fix your change in x, you're always going to get that resulting change in y. They'll be equal to each other. Okay? Then this constant multiple, the change in one quantity. So we want to talk about what is the change in y. It's always the same constant multiple of the change in x. And again, like we said, this is going to be the one that we're going to use a lot. And that was, I think the whole homework that you turned in today, almost every problem involved this, right? So it's just practicing this over and over again because we got to just understand it cold, okay? And then finally, the relative size of corresponding changes of quantities is constant. So how do we calculate the relative size?
The change in y divided by the change in
Ratio, right? A quotient. Relative size is a quotient. So the quotient of delta y to delta x1 is going to be the same as delta y to delta x2. It's going to be the same as delta y3 to delta x3. So that's going to be that ratio, or that relative size of changes in y to changes in x is going to be constant. What would you estimate that relative size to be in this case?
1.5 to 3.
1.5 to 3. Agreed? Something else? Uh-oh. Anybody have something different? Don't be shy. Ross?
1.5 to 2.5.
1.5 to 2.5. Uh-oh, I'm scared. What ratio is this? The ratio of what to what? No. Changes in y to changes in x. What's the relative size of changes in y to changes in x? Okay, and let's estimate that value. Is it greater than 1? No, it's not greater than 1, you guys. Why is it not greater than 1? Well, that's shorter, right? So you have a change in x, your change in y is less than the change in x. So the relative size is about a half. Ooh, that took too long. Does it make sense?
Yes.
The relative size of the change in y is about a half compared to the change in x. For a change in x, you get about half the change in y that you had for your change in x. And that's that relative size. So that k is about 0.5, 0.5. Make sense? Okay. And that's the constant rate. So our constant rate here is about 1/2. Okay. So that's review. Find that in the video. Go through it again. So let's, we want to talk about lines. So the days of y equals mx plus b are over, okay? We need something more sophisticated than that to really understand and build up towards calculus. Okay, so we're going to use constant rate of change to build up our understanding of and way of modeling a line. Okay, so here's the situation. You got two painters. They've started painting their respective houses. At a certain point, first painter has already painted 250 square feet, and the second painter has painted 400 square feet. So the pink bar represents? Does it represent painter 1? Sorry. Well, painter 1 is a person. What does that pink bar represent? That's right, number of square feet painted by painter 1. So this is square feet. So that's why I did P1, so I didn't have to do that. One more try. Feet squared by P1. How about that? And so then this is showing the 400 feet squared by painter 2. Is the amount painted by painter 2 proportional to the amount painted by painter 1? Is it proportional? Yes or no? I see a yes.
I agree.
Yes, some yeses. Okay, so what I'm going to show you is I'm going to say that painter 1 is going to paint 200 more square feet. Okay, I'm going to show that painter 1 paints 200 more square feet. Ready? Here we go. Maybe. Okay. So I just showed that painter 1 painted 200 more square feet. So what might the fact that the bars are thinner represent? So when I'm making the bars thinner, what might that represent? Okay, and how do we represent that? How do we represent an additional amount of a quantity? Delta. So this would be, and let's call the feet squared by P1, we're going to call that we're going to call that X, okay? We're going to call this Y. So this amount, 200 additional, we could represent as? Delta X, okay, of 200 there. And then so this thinner blue line here would be delta Y. The corresponding delta Y. All right, so we said this is a 2, so each, can you see those? Yeah, good. The vertical lines are 100 square feet each. Okay, so now I'll ask this question again. Is the amount painted by painter 2 proportional to the amount painted by painter 1?
Yes.
Yes. Sterling, maybe no? Why not?
Wait, what was the question?
The total amount painted by painter 2 is proportional to the total amount painted by painter 1.
At a single point, yes. But overall, no.
Okay. Any other you gonna say something or? Yeah, James.
The rate of change looks to be the same even though we started at different points, so I'd say yes.
Okay. Yeah, Melody.
I was gonna say the changes were
The changes are proportional, but the total amount is not. Okay, there's another theory. Other comments? Okay, how can we find out for sure? So if we want to look at the total amount painted by painter 2 versus painter 1 and find out the proportional, what can we do to seal the deal?
throw some numbers in there and see.
All right, tell me some numbers. So tell me some numbers, Kevin.
The total of P2 is 650.
Right now it's 650, is that right? Okay,
And then the total of P1 is 450.
450?
And then we just
Any other numbers?
and then where they started from.
Okay.
We have P2 at 400, and then we have P1 at 250.
All right, so maybe is there a more convenient way to organize this? You guys are so smart. No, let's wait till your test scores. Okay. So I have an ordered pair X and Y. What's my first ordered pair X and Y? 250 and 400. And then? Is this right? Okay, I'll ask you again. Is the total amount painted by painter 2 proportional to the total amount painted by painter 1? Yes or no? Find out. So work together, see what you think. Okay, where's Connor Stewart? Huh. What do you think? So tell me what he says. No. Why not? So you were comparing changes? Okay. If we want to know if the total amount painted by painter 2 is proportional to the total amount painted by painter 1, do we want to look at changes in the quantities or total amounts? Christian?
I'm just confused where we got the X is 450 from. Because if the painter only painted 400 square feet initially, so why is that in the X value?
So what I told, so here the setup was they've already both started, and all I told you was that at the moment that painter 1 had finished 250, painter 2 had finished 400. And then I said, okay, let's let them paint some more. So painter 2 painted 200 more square feet, and when he did that, sorry, painter 1, and when painter 2 did that, he went up to 650. So now I'm asking, is the total amount painted by painter 1, painter 2, proportional to the total amount painted by painter 1?
So the 450 in the X table should really be 400 then?
So is the table wrong?
Yes.
So I'm just leaving it up to you. I wasn't thinking about it. Is the table right or wrong? When X is 250, the corresponding by painter 2 is 400, and when X is 450, the corresponding amount. Yep, table's good. Phew.
Oh, okay.
You see? Table's okay. Is the total amount painted by painter 2 proportional to the total amount painted by painter 1? Gilbert.
First, did they start at the same time?
This is all the information you have right now.
I was originally thinking no, but I'm not sure if they start at the same time, so I don't know if you could figure it out. I'm not so sure.
So not enough information.
That's what I'm
Okay? Peter,
No,
why not?
because the ratio of 200 to 450 is 5/8, and then the ratio of 450 to 650 is not 5/8, it's 9/13 or something.
So the ratio of these two?
No, the ratio of 450 to 200 is 5/8, and then the ratio of 450 to 650 is 9/13. So since the ratios aren't the same, it's
So you took ratios of corresponding values like this. So he's saying this, the ratio of these two is not equal to the ratio of these two, therefore not proportional.
But aren't we interested in total?
These are totals. These are totals.
Isn't the first X and Y, that's just the initial?
But it's still a total amount painted at a certain point.
Okay.
There's still total amounts painted at a certain point.
And the changes aren't proportional either, so.
Okay, so we haven't asked that question yet. All we're asking is the total amount. So are we okay? The total amount is not proportional, okay? Because the ratio of y to x does not stay constant. The ratio of y to x does not stay constant, right? So 400 over 250 is not equal to, right over here, 400 over 250 is not equal to 650 over 400. So y is not proportional to x. Okay, so anybody need to ask a question? Is that cleared up? All right.
So all we were asking is y proportional to x. That's
I
it.
think I asked about 7 times. Is the total amount painted by painter 2 proportional to the total amount painted by painter 1? That's what we're asking. And that's our values of x and y. Okay. Does the amount painted by painter 2 vary with a constant rate of change with respect to the amount painted by painter 1? Okay, I heard no, and I heard we don't know yet. So how can we analyze that? How can we know if the amount painted by painter 2 varies with a constant rate of change with respect to painter 1?
Find K. Change
Find K.
Change Y over change.
Change in y over change in x. Good. Okay, so we know constant rate of change has to do with the relative size. So we're saying delta y over delta x. Is it constant? Yes or no?
We need to know where they started.
Need to know where they started.
We need another time interval to base off of.
Not enough information. That's what they're saying. Some people are nodding. Okay, fair enough. So now I'm going to let painter 1 paint an additional 300 from here. 1, 2, 3. Did I get it? Is that right? Now I got 2 tables to work with. So now you're going to build another table, keep working on the first table, build a new table, and answer this question. Is the amount painted by painter 2, does it vary with constant rate of change with respect to the amount painted by painter 1? Yeah.
What's the final values of here?
This one
Yeah.
is a quarter of the way from here to here. Does that answer it? So you're just going to have to count. You can count the lines. Each vertical line is 100. Each vertical, you can't see the vertical lines? Here's our 650, here's 400, 250, 450. So yeah, so we don't all struggle with this. Have some people found it? What do you got here? 1025? That's what I'm hearing. Are we in agreement? And how about this one?
Oh.
750.
750? Okay, so go. Does the amount painted by painter 2 vary with a constant rate of change with respect to the amount painted by painter 1? What's that? Oh, in terms of walls, that's not that big. Because one 10 by 10 wall would be 100. So if you had a big wall, that's easily 300 square feet. That's just one big wall, right? Is Alexander? Alexander, can you make some progress on this task? What'd you do? Tell me to your process.
First table, is change of y and x, and solve for k. And then for the second table, I did the same, and then I say k value.
Did you make a new table?
Yes.
What was the new table? What were the headings?
X was 450 and 750, and y was 650 to 1025.
Did you make a new table of new quantities?
Well, I could just put it in another table too.
Okay.
And add it.
So are you adding? I'm not following you. You're adding values here.
I added 300 to x.
And you got?
750.
Okay, so here, is this right?
Yeah.
Okay.
And then the y was, to that was 1025.
Okay. All right. Now okay. So we finished. You added to that table, and then where'd you go from there?
Then I did the change of x and y,
Okay.
and then solve for k.
And how many changes in x and changes in y did you do?
2.
You did 2. Okay. So can we make a new table for that?
Yeah.
Let's make a new table for change in x and change in y. So what was the first change in x and change in y that you did, Alexander?
Yes.
200,
200 and
and 250.
250. Okay.
And then the second one was 300 and 75.
Okay. So let's stop right there. Agree with this so far?
Yes.
So a change of 200, which would be from 250 to 450, corresponded to a change in y of 250, and then a change in x of 300 corresponded to a change in y of 375. Okay, let's have someone take over from there. Let's see, how about Christian? Did you do something like this?
Yes.
And then what'd you do from there?
Exactly.
Good, okay.
Alright, well, first I used that little change in y over change in x.
Okay.
Equal to k. So
Okay.
I did 250 over 200, which
Alright.
came out with 1.25. And then I did 375 over 300, which came out with the same result. So I'm going to assume my k is equal to 1.25. Therefore, the
So-
change is constant.
We got two ratios of delta y to delta x, and they both came out to 1.25.
Sorry, can you do 250 to 750?
I was so hoping you would say that. So then what's that? What's that delta x?
I don't know, I'm just asking you.
Oh no, you can do that in your head. You can do.
500.
How much is that delta x?
500.
500. And corresponding delta y? 625. Okay, go. If you haven't done that yet, do it.
Oh, that's the same thing.
Look at that. What, Nicholas? Nicholas? What was your conclusion?
It's the same K, 1.25.
Okay, so what's the conclusion? What's constant?
K is the constant rate of change.
We have a constant rate of change, right? So as far as we know, from just the data we have, we could say, yes, painter 2, his amount of painting varies at a constant rate of change with respect to painter 1. Okay? So we've got this number, 1.25. It's a very important number. So I want you to, with your partner, come up with as many interpretations of that number as you can. What does that number mean? In as many different ways as you can. Talk to your person next to you.
Maybe it is faster.
As much as you can.
My question
To delta x.
Using that one, it's not saying
It's just like whatever delta x is, delta y or whatever delta y is, delta x is.
Whenever x changes by y changes. Whenever x changes by 1, y changes by 2. So every change in y, 1.25 is a change in y.
Okay, let's see if you guys learned something. Where is Elena? Give me your favorite one. You got the easy one because you can pick any one you want.
It's scaled to 1.25.
What's scaled?
If you input a change of x,
Okay.
you would multiply that by 1.25 and then you can change y.
Okay, so can you say that same thing about with talking about the painters?
Painters, so if the second painter has a change of when he's painted, you multiply that by 1.25 and that's what you get for painter 1. No, for painter 2, sorry.
So
painter
let's start with this. So start with the amount painted by painter 2. The additional amount painted by painter 2 is always
1.25 times more than painter 1.
the additional amount painted by painter 1. And an increase in the amount of painter 2 is always 1.25 times the increase of, or the additional amount painted by painter 1. Okay? Yep, that's a good one. Very important. All right, how about Queen Wrong? Can you tell me another one? Interpretation of 1.25.
I think when y changes 1.25
Okay.
as fast as v changes.
Okay, so the
I don't know. I mean, painter 2 changes 1.25 times as fast as y.
and you can say paints. Painter 2 paints
Hence,
1.25 times as fast as painter 1. Yeah, that's right. That's you said it. You just said changes.
yeah.
But now in this situation, changes means paints, right? So painter 2 is painting 1.25 times as fast as painter 1. Good? Yeah. Chloe, you're up.
When x is increased by plus or minus 1, y will be increased by
So
plus
talk to me
or minus-
about painters.
Okay, when painter 1 increases his painting by 1 square, y will increase their painter 2 will increase their painting by 1.25
Square feet, right?
squares.
Yeah. Good, yeah. So for every 1 foot that painter 1 paints, painter 2 will paint 1.25 square feet. Did I say that right? For every 1 square foot that painter 1 paints, painter 2 will paint 1.25 square foot. Good. How about volunteer? Different one. Christian.
Every additional square foot that painter 2 paints is going to be the same size relative to painter 1's painting. So it's going to be 1.2 times relative to whatever, how many square feet painter 1 is painting.
Right. Yeah, so the amount that painter 2 paints is always 1.25 relative to the amount that painter 1 paints. That's like thinking about that ratio, delta y to delta x. Another one. Is there another one? Yeah, James.
Every variance in the amount of square feet painted by painter 1 is a constant multiple of the corresponding variance in the amount of square feet painted by painter 2.
So you're just saying delta x is some constant of delta y?
Yes.
Yeah, so there's some k, say k2.
0.8.
Is it 0.8?
Yeah.
Yep, true. Okay, so were there any more from our list that we missed in this context? trying to think. Oh yeah, we did miss one. So I heard it over here. Someone said it over here. Okay, so the total amount painted by painters is going to be in a linear relationship in Cartesian plane. That's true. But all these things that we're saying are the mathematical result of what idea? What's that? Constant rate of change. Okay.
Changes in however many painted, however many square feet painter one is painted are proportional to changes in however many square feet.
Yeah. The changes in the quantities of the two painters are proportional to one another, right? The changes in the quantities are proportional to one another with a constant rate of change of 1.25. Okay, so let's talk about a linear. So what do we need to do then to see this linear relationship? We got constant rate of change, so where does the linear relationship come from? What's that? Graph it. So, but tell me, so graph what?
Well, you have the table with the changes in X and Y. If you graph those as points, it'll be a linear line.
Graphing the changes will give a line. What about graphing the total amounts?
No, because those aren't constant.
There'll still be a line, it'll just won't go through 0, 0.
Okay.
It'll be we'll have a Y-Intercept somewhere.
Okay, so we have two varying views. So will the total amounts of the amounts painted, will that form a linear relationship? You saying yes?
I'm saying
yes. Yes, okay. So how can we see that? What do I need to do to this image to see that?
Put, 250, 400, and then graph each additional amount on just the total amounts. You'll get a straight line with a slope of 1.25.
Okay. Yeah.
Can you connect them and then do the little plane with the little trail?
Right. So let's start back at our original amounts. What do I need to flip? Need to flip painter 2. So I flip it up onto painter 1 like this. And then we start observing changes in the quantities taken together. Then how do those total amounts graph in the XY plane? Okay, so let's turn on the vapor trail, right? Turn on the vapor trail. So the thin line is our change from our original starting amounts. Okay, so the black is, what does that black line represent? The black line, when you look at that black line, what does it mean? What does it represent? What's that? The total amount painted. The whole thing.
Oh, wait, no.
Changes in Y relative to changes in X.
The black line represents changes in Y relative to changes in X.
Isn't it just the rate that they were going?
It represents a rate. What's that? That's right. I want you to think. I want you to think. I didn't ask you about the slope of the line. I asked you about the line. What does the line represent?
It's the amount painter 2 painted relative to how much painter 1 painted total.
Okay, is that the line? So now we're getting closer. This is the best answer so far. Go ahead.
Well, each point on the line is going to be the amount painted at a specific point in time. So the line is not the total amount painted, but it's the amount painted for each specific time.
Remember talking about this? What is a line? It's a bunch of points, right? It's just we can't show it that way because it takes too long, right? It takes too long, but that's what we have to see. You have to see it as a locus of how many points? An infinite amount of points, okay? So, and then each point, Ross, is what?
The amount painter 2 painted relative to how much painter 1 painted.
You said it was better before. That's a ratio. That's a quotient. You just said relative size. What does each point represent?
The total amount painted.
The total amount painted. Tell me your name again.
Jonathan.
Jonathan.
It's the X coordinate will be the amount painted by painter 1, the Y coordinate will be the amount painted by painter 2 at that X coordinate.
That's right. It's a package of information. It's two pieces of information. It's how much painter 1 painted and the corresponding amount that painter 2 painted total. Okay? And so the line represents all possible associations of how much painter 1 painted to painter 2. So lots of you were talking, when you were answering my question, you were talking about the slope of the line. So you all know your formula for slope from the past. What's the formula for slope? Okay, I heard y2 minus y1 over x2 minus x1. But look, what is y2 minus y1? Change in y. And what is x2 minus x1? And what's change in y over change in x? Okay. So the visual representation of our constant rate of change, we know it's delta y over delta x. Well, that's the slope of the line. Okay. So what happens is, what did we start at? What was the point we started at? 250, 400. And so how can I represent an increase of, say, 250 square feet from there? How can I represent, for painter 1? I want painter 1 to paint 250 more square feet. Oh, you gotta, sorry, totally ignore these numbers on the scale, okay? The gray lines are still 100 square feet, so totally ignore the scale. So this is 200 here.
So would 2 be 300?
So how can I represent an increase of painter 1 of 200 square feet?
Go to the right on the graph, 250.
That's right. Did I say 250 before?
Yeah.
So there's a delta x of 250. And what's the relative size of my change in y to that? 1.25. How can I calculate that change in y? What is it?
1.25 times.
Changes in y are a constant multiple of changes in x.
So 312.
What is it?
312.5.
See, so now our change in painter 1 is represented horizontally, resulting change in painter 2 represented vertically, and that increase will always be 1.25 times as much as the increase in painter 1, increase in the square feet of painter 1. Okay, so let's do red. So now I'm going to change x by, this is at 300. 600. So analyze that. So here's a change in x of 600. You finish the story. Go. Change in x of 600. Finish the story. Don't count. Use the math. Use the math.
No, I did the math.
Okay. Or just seeing if it's right.
I'm seeing where it would fall on that.
Okay. Austin, tell me what you think. What does that mean? You said 1.25 times 600. What will that give you? So it's the total amount painted by painter 2? The change. Corresponding to this change in x. How can I represent that on the graph? It's the best vertical line I've drawn all day. All right, and what is it? 750 square feet. Okay, so we know that our starting value, so look, we started with a change in x. And that was from, what, 250 to 600, right? No, 250 to 650. How did we get the resulting change in y? 1.25 times the change in x. So how can we find now the new total amount that painter 2 has painted? Somebody new. I want to find that new, using all this stuff. What's the new total amount? Nicholas?
Add the change in y to the initial.
And what was the initial?
I don't know. What was it? 400?
Yeah, 400. So 400, and then you want to do what?
Add where we ended up, at 750. Oh, so the change in Y, so that's 350, so 400 plus 1.25.
Oh wait. This is, sorry, what am I doing? This is 600, right?
Yeah.
Sorry. Yeah, if I make a mistake, please, and you notice it, please speak up. Is that right? Now? What's going on here? I'm trying to reproduce this red situation over here. Delta X, we started at 250, and where did I go to? I didn't go to 650. Where did I go to? No, I went to 850.
Oh, okay.
That's an arrow. Okay, sorry for the confusion. If you were confused, good. Okay, that means you were paying attention. All right. X went from 250 to 850, meaning a change in X of 600. So to get the change in Y, we take 1.25 times that. All right. So now we want this value of Y here. So we know that our X is 850, and we're asking now how much is painter Y painted. So Nicholas, talk it through again. So we want to get this amount that he's painted.
So you want the initial,
Uh-huh.
and you want to add the change to that.
Okay.
And our initial was 400.
Right.
And our change was 750.
Right. So isn't this the idea that the new value of Y equals what? I'm going to call it the old Y. Plus, that should make perfect sense, right? You got a value, you change it by so much, you're going to add that change to get the new value. Okay, so this is the idea. This is how we want to see linear functions. We're using constant rate of change. Here's the key, right? We said that changes in Y are always 1.25 times changes in X. So we want to build our linear equation from this process right here. You start with a change in X. Given the constant rate, you know what that corresponding change in Y is. And then we have the last thing, the new value of Y will just be your starting value of Y plus the change in Y. Okay? So to get our equation of the line now, we just want this point now to represent any point on the line. And we'll just go through the same process, and we're going to end up with the equation of the line. Okay? So we'll start again, and we're just going to, let's start at, we can start at a different point too. So what was another point in the XY table that we had? 450 and 650. So this is 200. So I think 450 is right here. So that's where we're gonna start. 450 and 650. And now we're gonna say, okay, this is we're just gonna pick any point on the line. So I could have put this point anywhere, and we're gonna call it what? X, Y, because it represents any or every point on the line. And we're going to go through the same process. What's the first step? So here we are. Painter 1's painted 450. Painter 2's painted 650. What are we going to look at first? Delta X.
So that would be 450 plus X.
450 plus X. What do you think about that? What's the change in X? We start at 450. Marco.
X minus 450.
X minus 450.
Yeah.
You changing your mind?
Yeah.
Good. Okay, so delta X is going to be X minus 450. Okay? People who understand what we're doing right now run circles around people that all they know is Y equals MX plus B. Okay? Because you know what's going on. All right? Where are we going to go from here?
That's Y equals.
Delta Y. So given a change in X, there's a corresponding change in Y. Kevin, what is it?
That's Y equals K times X minus 450.
And what is K? Yeah, K delta X in our case equals 1.25 times X minus 450. Somebody take over from there. So what is our goal? Our goal is that right there. We want to know the final value of Y. Chloe.
If you know that value, you can find the change in X, using the slope, which is going to be the K value, finding that X is going to be.
Okay, but just in general, we're after this final value of Y. Ryan.
So the final value of Y would be Y equals 650 plus the 125 times X minus 450.
We know what our old or starting value of y plus what?
Plus the new value, which is the 125 times x, 450. That's the new
No,
value.
no, what's this again? It's not the new. That's change in y, right? You had the right thing. No, you said it was the new value of y. That's how much y changed.
Okay, then
So you start at a value of y, and then you have its change, and you end up with this value of y. So, old y is 650. Change in y is? See, now we have an equation where we know what everything means, right? And it represents every ordered pair, x and y, or amount painted by painter 1 and associated amount painted by painter 2. Every single one that we can do. Okay? X minus 450 represented what again? Change in x. Multiply that by 1.25. Change in y. Add that to 650. You get the final amount painted by painter 2.
I have a question.
Yes, please.
What is the Y-intercept? Is there a
Okay.
Y-intercept?
Let's do this. Okay, so do the same process again to find the y-intercept. So from here, so let's start from here this time. And this was what, 250, 400? I'm gonna do it in red. So y-intercept will be the red. 250, 400. We want the y-intercept. What's our change in x? Is the change in x 250? Negative 250.
Yeah.
What's your final answer? So from here to when painter 1 is painted 0, how much did x change? Negative. I was waiting for your final answer. Negative. Corresponding change in y. 1.25 times that, which is how much? Crank it out, quick. It's not negative, what? I don't want to put it there. Negative 312.5. Final value of y, how do you find it? Starting value of y plus the change in y equals 87.5. So y equals 400 minus 312.5. So the starting value of y plus the change in y, 87.5. So what does this point 0, 87.5 represent? No,
So it's when
When painter 2 first got into the scene, painter 1 was 87.
yeah, you got it. You got to put it. When painter 1 had got to the scene and started, painter 2 had already painted about 87, 88 square feet. Okay. Have a great weekend. I'm going to post homework for Monday shortly. Great class, you guys. Good job. What? Oh, thank you very much.
Did you get any responses on the email?
I got 4 exactly.
Oh,
Yeah. So
yeah. I met with Dr. Carlson yesterday. He's got problems and prompts picked out.
You like them?
Yeah, pretty good. A lot of good questions.